So my name is Chris Atkinson. I'm a solutions architect here at MarkLogic. I spend the vast majority of my time, and by vast majority, pretty much all of it actually, working with financial services institutions, and mainly out of Europe, but of course with most financial institutions, they have global footprints. So I'm exposed and helped deliver over the last couple of years a number of solutions that help our customers develop a trade store. So the question probably first in your mind is what is a trade store? And it is as simple as it sounds. It is a repository which allows you to store information about your trading activities, orders, trades, transactions, reference data in a single location, enable for you to provide typically some level of regulatory reporting. Now, this session is intended to be much more of a practical session. I do have a session at 1 o'clock, so I'm going to selflessly plug my next session at 1 o'clock, which is actually much more about the higher strategic level of what you might want to achieve. It would have been good to probably do the other way around, but there we have it. Really, this is about if you are in the position where you're looking at a trade store, you may even have a trade store, or you're looking at developing a different way of managing your data or satisfying your imminent regulatory requirements, then this is the session for you. Before I go further into it, though, I'm going to ask the question, which is there anybody in this room who is not from the financial services sector? Okay, that's interesting. I'm going to ask the question, actually, just for a couple of you. What drew you to this session? I'm going to guess it's the golden source of truth. Right? And I'm trying to, so now that we've got people I didn't expect, I'm going to basically sit around like, these rules, whether it's financial services or not, are good practices no matter what you're doing, right? So we'll keep it interesting for you guys who are not from that realm. So the first question is, why do we need a trade store? Fundamentally, right now, there is a massive shift in the amount of information that we have to provide in a timely fashion to the regulator. And the restrictions and the rules that govern what we publish and how we publish to the regulator are shifting as well. 10, 15 years ago, there was a subset of data and you sent it. Now there is a subset of data that has a number of rules applied to it that guarantee whether the data is eligible for reporting, whether there is information that has to be derived from that reporting. You may actually have to look up to not just reference data, but the regulators themselves to derive new information. You may, in fact, have to create and publish new information to the regulator in order to make your own information complete. An example of which would be an ISIN code, right, an instrument identifier. While that's going on, while we're seeing increasing weight and pressure from the regulators, what that's driving on the business side is us using our existing technologies to try and fix that. And the challenge there is that the existing technologies, whilst not very agile, mean that we are always putting more people on the job, trying to automate more tooling, more process, more pressure around trying to deliver that. And that becomes a fairly insurmountable issue over time. Now, why is that such an issue? Well, it goes back to something that you've probably heard a lot about over the last couple of days, which is all about data silos. Financial institutions love silos, okay? And they love silos for two reasons. The first one is that the silo is incredibly agile, right? If I was starting up a business and I didn't have to pull information to a single location to gain transparency, I would make sure that every single person has their own silo of data because they can manipulate it, they can change it, it perfectly represents their own needs. The challenge is that those silos don't provide a transparent view either to the business or the regulator, and that's where the pressure comes from. So what we do is we stitch all of those silos together with ETL processes. We may publish information into a warehouse. The challenge with that, and the reason that's not perfect, is because even though we're publishing this information, we're only publishing what we know about. We're not publishing the information that is newly created. If I create an attribute in my silo today, there is no way that is going to be published into my data warehouse by the end of today. So we're only seeing a subset of information. Also, by stitching all of this together, and I'm from an operations background, what we do is we start to create lots of change control process that restricts when we can make the changes within our organization. Is there anybody here that can hold their hand up and said they haven't been held back by a change control process in the last 12 months? Okay, loaded question. That's the problem. And some of these problems become incredibly, incredibly important when you start to think about the future and how the future's evolving and the speed and rate at which both the business wants to evolve and the regulator's demands upon you. So the question you should ask yourself is, I'm doing this way now, unless you're already a MarkLogic customer, which congratulations and good choice. When is enough tooling enough? When can I start to think about, or how do I start to think about using the pressures that I'm getting from my external regulators, the funding that my business is having to make available to do this, and actually make a step change and do it in a better way? When is enough tooling enough? And that's when you can start thinking about MarkLogic. And the fundamental difference is, so when I speak to people about this, they're like, that's really interesting. We know that we agree with the problem. We know we're spending a lot of money here, but simply, why is MarkLogic going to help us do it? And the simple truth is, we are a multi-model database. Who's heard the term multi-model? Okay. Who's heard the term multi-model not from a MarkLogic person, but externally? Okay, that's interesting, because in Europe, that's a very common term now in financials, but I don't think it's translated over to the US. What would you guys refer to it as? Is there an equivalent term? Matter of interest? Okay. A multi-model database does exactly what it says on the tin. It allows you to put multiple data models into the same database and then search and query it. It's that simple. The benefit of that is that you gain transparency because all of the information is held within a single location. But additionally, because everybody is still representing their information within the original models that represent their own processing and their own functions, you regain a large measure of that agility back again. One really important thing to remember as well is that the reason why banks also like secure silos is because they're very secure. Okay? So if you're going to do this, a really important thing of your multi-model database that you need to look at is the security of it. You need to embed that security within the data models that you're ingesting in order to make sure that you don't break down the secure silos that exist in the actual roles and functions themselves. So this is intended to be a practical session. And unfortunately, I couldn't boil it down to 3 steps. And I couldn't make it 10 steps, so I've got the rather awkward number of 9 steps. So I apologize for that. If anybody can suggest 10 steps to me, I'd appreciate it, or drop it down to 3, that'd be great. So we talk about multi-model. How does MarkLogic work in a multi-model? Well, it's really simple. The data that we ingest describes itself. Okay? XML describes itself. JSON describes itself. So that means that we ingest the information as is, and we ingest the information as an entity. So what you see here is something that the financial services guys in the room are going to be fairly familiar with, which is kind of a high-level view of what a trade looks like. There is information within that trade. If we were looking at that from a relational perspective, we would break these key kind of attributes out, right, into separate tables, and we create foreign and primary keys. If we bring another piece of information into the database, which is a piece of reference data, so for the non-financial guys, reference data is just facts about the world, right? That's all it is. Then we can see here that we've got some more information, and the power of MarkLogic allows us to query and join between these 2 attributes that are common to the 2, which in this case is the legal entity identifier number. And that's the really simplistic option that you have with a MarkLogic solution. You plug the data in, you ingest it as is, and then you can query and join the information across your environment at runtime. Now, what you need to remember is when you start this project, and actually I can probably put step 1 here, so maybe I've got my 10 steps already. But it's not really a step, which is think about your design philosophy. That's kind of my first piece of advice. And the design philosophy of building your solution needs to match the MarkLogic's design philosophy. And the good ones that our customers use are these 4. Load the information as is, okay? Don't think necessarily about pre-tagging it, pre-loading it, pre-ingesting it, pre-processing it, unless there's a really, really good reason to do so. Okay, so ingest it as is. No data left behind. Absolutely do not put rules in front of your MarkLogic database, in front of your ingest streams. Ingest everything as is. The reason being is you want to at least have a complete view of the data before you decide what is relevant. Okay? 3rd step, empower the consumers. And what I mean by that is your consumers know more than your DBAs will ever know about your data, right? Because your consumers are typically liaising directly with the people who are generating the data in order to request information, request the attributes, and guarantee that all the information that they require is there. So putting IT between that conversation just gets in the way. So ideally, what you want to be creating is something that allows the information to be explored and derived without a DBA getting in the way or a developer being required to surface that information to your downstream consumers. And iteration. This is an iterative process. The power of this solution is that you don't have to build your data model in advance. Okay? You're doing it as you go along. It's like a jigsaw puzzle, right? You don't sit a jigsaw puzzle up on your desk at home and plan on a piece of paper which pieces you're going to move where, right? It would take longer to do the planning than it would to actually do the actual jigsaw puzzle itself. And when your child comes into the room and slams the door and the draft moves them all across the table, you have to start from scratch. And that's how the business world works. Data is a constantly moving and evolving target. It's like trying to nail fog to a wall to try and plan the data model in advance. It's super difficult. Much better to ingest the information and then work out the information that you need to derive from it and the metadata you need to derive from it as you progress through your journey. So step one, are you building a regulatory requirement? Are you just satisfying a regulatory requirement? Are you building something more long-term like a data lake, or are you building a Lego Starship? Okay? I'm putting Lego Starship there because it's completely off the wall, but I can guarantee that if you've never used MarkLogic before, as you start going down this process, other consumers and other use cases start to emerge very rapidly from other people within your organization who look at it and they say, that's really cool. I want a piece of that. Okay? The trick is to look forward and see and start to think about the designs that you're using and making sure that they're future-proof in terms of what you're going to build. Okay? But stay very focused on the immediate requirement of what you need to do tactically now to achieve whatever it is, your regulatory report. One of the key, so step two is design your data architecture. And this isn't really designing the data architecture so much as thinking about how your data works within MarkLogic. Who here now has not heard of the envelope pattern over the last couple of days? Okay. So everybody knows the envelope pattern. The way that I like to break things down with the envelope pattern is in these two ways. I break things into what we call the core attributes and the dynamic attributes. The core attributes are the thing that your data model hangs off. They're the primary keys, the secondary keys in your relational world. The dynamic attributes are the things that change all the time. You need to identify what they are only to identify what your core attributes are. And I'll talk about some of the process around how you do that in a moment. Once you've identified those, what you might want to do over time, optimizing it, is you might start wanting to promote some of those core attributes up into the envelope. Promoting them means that you can make them faster for joins, faster for queries, and you can expose those harmonized common attributes to your downstream consumers via a DSL or an API. So you start to simplify the process of exposing the information to your consumers, but you're also optimizing the performance of the system all the time. In addition to those core attributes in the envelope, you'll probably put some system attributes in there as well. If you need to use our bitemporal capability, there might be some timestamps in there. And very, very importantly, and I'll cover this in a lot of detail in a second, is hashing. So you might want to start thinking about hashing the data as it arrives and creating a unique fingerprint for it for duplicate checks. The third step is really a procedural thing. Create this person. The technical business analyst is going to be, during your implementation stage, the most important person in the entire chain of your delivery. They need to be a MarkLogic aware person. They need to understand it. Okay? Now, the reason why this person exists is they act as an interface between the developers and the real business logic people, the real business analysts in the business itself. Their job is to help determine several factors, both functional and non-functional, and then translate those to our developers, or your developers if you're using your own. The first step is that if you're trying to satisfy a distinct regulator report, then you'll have a list of fields that you need to deliver, and you need to determine where do those fields come from? How do I generate them, or is there a gap? Excuse me. So the technical BA will work with the business BAs and effectively classify all of the outputs in this form. So first of all, what the type is, whether it's a dynamic attribute, we'll go through some of the attribute types in a second, and whether it actually exists or not. So in this case, we've got a dynamic one. Now we've got two core ones, and actually these core ones are derived. What derived means is that we actually have to look that up. So it's not actually contained within the transaction that we receive. It could be a piece of information that is derived from reference data. So the lie and the ISIN are great examples of that. They're probably not going to be contained within the trade itself. You'll probably have to go and look them up. You'll derive them from somewhere else. And then you have the problem child, okay, which is what I would describe as the complex attribute. A complex attribute may be something that has to be calculated at some point during the process. And it may be a gap. It may be a gap because you don't know how to process it. It may be a gap because you don't have the actual data in order to calculate it. This BA will often pick up on those and then push them back to the business BA, and the business BA will push to the sources, and the sources will then generate that information, allowing us to create the rules that are then provided to the devs that are effectively then delivered. So just staging it in these kind of, to basically present, derived, and gap is a really good way of managing that interface between the business and the actual execution and delivery of the solution. But they're also as well responsible for agreeing with the architect, that would be me, what the best output types are for the different regulatory interfaces, what the operational processes are behind that. This is something we often don't think of, right, until quite late in the day. But it's good to get a good picture of who is actually going to be running the application, who's going to be running the database, okay, because those are two slightly different areas. And then ultimately, what level of abstraction do you want? And I say what level of abstraction because MarkLogic is pretty powerful, right? You can run any query across MarkLogic, okay? And my recommendation is that if you've got several billion trades, you should absolutely allow that. Isn't that right, Justin? That's terrible. You're supposed to say, no, Chris, you're crazy. Just like a relational database, you would never, ever set up an index on every single column in your database and open up an API allowing every single one of your consumers to run any query they would ever want to run. Because no system on the earth can cope with that. A DSL and an API are great ways of abstracting and controlling what gets run across the environment. And it's a brilliant method because if you set up the dimensions within MarkLogic and optimize those, say you've got very, very high-performing memory-based indexes, if somebody comes along and says, I need one of those for my work use case, and the BA liaises with them and truly identifies whether that is true. The biggest problem is when people go, hey, that's a really good index, that's a really high-performing one, I'm going to use that to solve my dev code problems. Yeah? That's where the technical BA can turn around and go, actually, there's a better way of doing this. We can create a harmonized version in the envelope that satisfies yours and another person's need, or actually there's a different way of doing this entirely, or yes, we should do that. So the technical BA is a really, really important role. So you've got your business analyst set up. You've got a good idea of what your outcomes are, the philosophy that you're going to achieve, and where you're going to go with the solution in the future. The next stage, of course, is, well, we want to start integrating those silos together and pulling data in. So how do I get my source data into MarkLogic in the most efficient way possible? My advice here is whatever suits best your organization. Okay? So that's a bit of a woolly answer, but I'm a massive fan recently of MQ and MQ-FTE, if you have either of these technologies. So MQ, it's a standard messaging queue, right? Most of you are probably familiar with it at some level, okay? MQ-FTE is exactly the same technology provided by IBM. There are various other ones, Tivoli do similar. But the difference is that MQ-FTE provides file-based delivery as well. The reason why I'm a big fan of these for delivery of information is because they provide high levels of availability for the ingest queue so that if anything goes wrong anywhere, the separation of concern is a result that if it's not in MarkLogic, it must be in the MQ, and if it's not in the MQ, then it must be in the source system. It's a clear, distinct demarcation of responsibility. It also means that rather than placing files and messages potentially on a file share and having to worry about how you integrate that into your Java layer and make sure that that's highly available, the work is done for you. Now, connecting that into your MarkLogic base is pretty straightforward. Most people use some Java interface or another way of pushing it in. We have, REST interfaces, so it's entirely up to you effectively what the mechanism is that you take from the MQ and push through. And you push that through a load balancer, so pretty standard fare. What is important, and I mentioned it earlier, which is hashing. If you're going to build a trade store, you absolutely need to put a hashing algorithm in front of the ingest. And this is the only time that you will violate that rule, which is ingest everything and leave no data behind. That hashing check will take the information from within the message itself, it will perform a calculation and basically generate a hash, and if that hash matches an existing hash within the database, it will reject the ingest. It won't cause an exception. It is an absolute duplicate of something that is already in the database. And this is more of a non-functional solution to anything going wrong in the streams up above where somebody republishes information into the MQ. You don't want to duplicate that data. It's the only time you will do that. What you also might want to do as well, actually before I move off the duplicate checks thing, one of the things a lot of people come up with on the hashing is how expensive this is going to be to do at my ingest time. Okay? The good news is that if you're running the Intel V3 processors, they are massively optimized for floating point encryption operations. And the hashing algorithm uses exactly that optimization. So the actual cost of doing this hashing is very, very small. Okay? In terms of the kind of last stage of that ingest process, validation. Now, validation can take two forms. You can do it really, really basically. You can do, an XML-based validation. But for financial services, typically speaking, just a simple XML, which is, is the type right, does it exist, is not sufficient. Normally, certain checks need to be raised against the incoming data to identify whether it truly is valid. Does it have a valid lie? Does it have a valid ISIN? Is the nominal value been recalculated? When was the last time it was operated on? Lots and lots of stuff. Those validation rules aren't satisfied by a simple schema. So actually, what you might want to do is something that I recommend is using something like Schematron, which is an open source project that allows you to perform extremely complex validation rules within the document or even look it up elsewhere. So that's a good solution to apply as well. One other point here is, and I say here, return your quality issues. What I mean by that is, if there are data quality issues that are raised by your validation, do not fix them inside the database layer. Push them back up. Now, the only time I've ever seen real problems with this kind of architecture is when that doesn't happen. Yeah? Because the hashing starts to fail. Right? You're going to be manipulating information, you're going to be changing information under the covers. What you need to do is make sure that the people who are publishing information into you, if there are data quality issues with it, they are responsible for them and they push back up. Now that trend has been happening for probably 4 or 5 years now, definitely, which is, the DCOs within various businesses are making the sources responsible for their own data quality. Politically, it's a good thing to do anyway because nobody wants to clean up anybody else's mess, right? And if you're cleaning up the mess, people keep making the mess. So it's a good thing to get right. Getting kind of through it now, we've got the data in, we've got a harmonized version of it. What about processing and actually generating the reports themselves? And slightly contentious, but I would say what you don't want to be doing is creating this kind of a scenario. Historically, people pumped information into the databases, they left it there until the end of the day, and then they processed the hell out of it. And what you get is a tidal wave of back-end processing towards the end of the day. It's much cleverer to actually do something like this, right? Which is either do some processing at ingest time at potentially the cost of creating a wider structure in order to accelerate your ingest and keep the throughput up, or you can actually reprocess the information after ingest with a post-process. So let it land. Most of the regulatory reports that people deal with the exception of real-time reporting, which I'll cover in a second, those kind of reports are typically end of day, right? Most of it is, and the technical term that is handed out by the Basel Commission is as soon as practicable, right? Which is geared to be basically within 5 hours or whatever it is of the end of the day's trading. In fact, actually, some people say within 24 hours. What's really important as well is that you start to think about how you track information through your environment. A couple of faces I spoke to yesterday, actually, in the audience about the provenance or the supply chain of information. The session this afternoon, I'm going to talk about FRTB in some depth. The big shift that we're starting to see now is that you're not just reporting, but how did you report? Yeah, and the full traceability of where the information came from, who acted on it, who accessed it. So whether you have an immediate demand for that level of provenance of your information and your data supply chain, it's a good idea to implement the Provo ontology now because it'll give you the capability to report things like when did I report it, who reported it, when was it re-reported, things that you will want to do. right? Because you will always want to say, when did this information get accessed? But it's a good stage now to put that in place, because you will, in all likelihood, want to extend that, and there's no significant cost to doing it. So this is the big one, right? I've got my end-of-day reports, brilliant, but the big question is I've now got real-time demands. So within Europe, we have a regulation called MiFID II. Anybody heard of MiFID II in the room? Okay. So MiFID II has some unique demands about it. And one of those is that you must now report in real time certain types of transactions. And you publish those through to something called an APA, which is an authorized publishing authority. And that needs to happen within 1 minute. And that's not within 1 minute of hitting your aggregation layer. That's from execution to APA, 1 minute. It's a pretty tall order, right? It's a tall order when you think about stressful situations, okay? And I'm not calling out Donald Trump or Boris Johnson as being particularly stressful, but what they did do is they generated, when they happened, massive spike loads. So I was at a bank in Amsterdam, and they experienced an 8-fold increase in trading activity when Donald Trump was actually elected. Okay? You'll be happy to know that Boris Johnson actually trumped that, literally, with 14 times trading activity. Okay? So I'm not sure what's more worrying as an English person, to be honest. So here's the thing, right? There is a brilliant capability within MarkLogic, which is the REST function. So the REST function allows us to, when that validation, that processing has happened at the point of ingest, and when we've identified that the arriving transaction or trade is eligible for real-time reporting, we can fire a REST call down to the Java gateway layer containing the information about what the trade is, and then the Java gateway communicates with MarkLogic to fetch the data and then publish it out, either to an MQ or basically another mechanism. The nice thing about this approach, it's very, very simple, is that it puts the load back onto the gateway. Okay? You're not queuing up vast amounts of information within MarkLogic or any excessive processing or memory loads. You're basically putting it back on the Java gateway, and that is the thing that you can scale really rapidly. This is the thing that you put basically CloudFormation templates on in the AWS cloud to scale out rapidly in order to satisfy that, or automatic provisioning templates within your virtual environment in order to scale that environment rapidly. So this is a really, really nice and clear architecture that helps you deal with spikes and alleviate the load on the database itself. The thing that keeps me awake and the thing that this actually mitigates is I don't worry about spikes per se. What I worry about is unpredictability. If I know that I'm going to increase my load by 10 times and I'm going to have a 10 times overhead, then that's fine, that's predictable. But my big worry is what happens when things don't get served and I start to get a spiraling effect out. And this is a really nice solution to getting around that. Now, data quality is a paramount concern, and particularly making sure that you have completely reported everything that you need to. Most of the regulators will not, in fact, none of the regulators will punish you for identifying within 24 hours that the data you sent was incomplete. If you keep doing it, day in, day out, then yes, you will be punished for that. But of course, the key is identifying, first of all, that you haven't done the data completely, and then remediating it. The key to that is quite straightforward and simple. First of all, at the end of the day, you ask the sources to send a reconciliation list. At the end of the day, your downstream systems, in this case I've taken the MiFID example of an ARM, which is an authorized reporting mechanism, and an APA, from basically they send their reconciliation list back to us. What we then do is within the database, we reconcile those, we identify using the provenance ontology, was it reported? Did we think it was reported? Did we even receive it? And if not, then what happens is we then raise those out to our business operations folks, and then they either re-request the information from the sources, or they perhaps do some matching and process handling in order to identify why the information was in the database, but it wasn't received, or just simply resend it. And this is a nice, simple process. Another question that was actually asked quite recently from a customer was they started to build, because they didn't want the regulator to turn around and say your data is invalid. So they started to build the logic here within the trade store itself. And that's a really bad idea. So it's a really bad idea because the regulator is, you can't actually define what the regulation is, okay? Because a regulation is written in such a way that it's typically quite ambiguous. And you negotiate effectively what that regulation means to you. And the reason for that is, legally, if they write down hard in stone exactly what the regulation is, all of the banks will find a way around it. But by making it ambiguous, then it means that it has to be agreed and it's more difficult for you to work a way around. So the challenge is that you will never perfectly match your logic to whatever is in that downstream regulator's kit bag. So don't bother. Yeah? I actually call it the egg test, which is you throw the data at the regulator, and if it breaks, then you know that there's something wrong with it and you need to fix it, because don't worry, they'll let you know. Okay? Then you fix it, you remedy it, you revalidate it, and you push it down. Simple. Now this one is something close to my heart, which is, and it's something that a lot of people leave right to the end. Right? Most people start to think about the non-functional aspects of the architecture right at the end, particularly with regard to data lifecycle management. Here's the thing, right? Every single MarkLogic sales guy would love you to basically think about this after the project's finished and you've got data spiraling out of control, you're holding 20, 30 years of swaps within your system. That's great for us as a business, but it's not good for you as a customer, and actually we're pretty focused on your success as well. So our advice to you is this. Instead of thinking about how you manage data, how you archive data, and how you manage the SLAs around data after the data's in the system, it's much better to start doing this when you're onboarding the systems. It's a much better negotiation to have, because it is a negotiation with the business typically, right? What kind of information do you want to hold? What's the SLAs on this? If you want to keep all your data on a tier 1 platform, Mr. Customer and Mr. Consumer, then that's absolutely fine. But that's more cost to you if you're doing cross-charging. This is the stuff that you can agree up front. It's the technical BA who will help do that, right, in combination with your architect. Another tip, very, very tactical, regarding backups. The great thing about MarkLogic is HADR is covered, brilliant. Your backups are covered, just a thing. Always put your backups in a shared location. It makes management of them much easier. Once they're on a shared location, you can then archive those, stage those off using your enterprise backup solution. Again, think about leveraging your existing enterprise standards rather than creating whole new ones. The final stage, thinking about the jigsaw puzzle, there's always that point where you get in there and there's like your last 15 pieces and for some reason one of them won't fit, right? Because you got something wrong somewhere else. And that's how it works, right? That jigsaw puzzle is still legible. You can see the picture of the data, right? But you just need to get a few things right. Consider that all the way through with MarkLogic. There are many, many different ways that you can develop, higher performing data models. You can change your architecture layout within MarkLogic itself, and you can do all of this on the fly. So you don't need to get it right first time. In fact, you're not going to get it right first time, and it doesn't matter because it'll still work. You'll still get the outcome you're after, but you can optimize this over time. And that kind of covers off the 9 points I wanted to cover, to be honest. So before I wrap up, I'm just going to ask you guys what questions you have. Hi, yeah.
So, what's the volume of trades that you're doing in ES? How does our project deal with
So the question is effectively, what is our experience of dealing with high ingest loads? Yeah. Now, high-frequency trading, that's an interesting one. Okay, so obviously we're never going to act as the backing store for a high-frequency algorithmic solution because most of that is held in memory. But we're pretty good at being a persistent store for that. The biggest implementation, the fastest implementation we have at the minute ingests around 45 million trades per day during the working day. So that's basically 8 a.m. until about 4:35 p.m. in UK time. So it's pretty big. However, we're currently looking at a different solution for another customer, which is likely to quadruple that. Now, the thing is that the question is not really about how much you can ingest, because we can actually create a very wide cluster that it can ingest extremely aggressively. The question is what the shape of the data is and whether you can join. If there are hundreds of different types of joins within there across different silos, how do you satisfy that in a performant way? Does it have things like real-time reporting around them, all that kind of stuff? So I'll let you know on the 1.5 terabyte every 5-hour ingest. That's something we're working on at the moment. Big thing is the shape of the data, really. But yeah. So that gives you an idea. We're pretty good at doing big scale out, high transactional throughputs. Right.
You mentioned regulatory reporting early on in data quality. A lot of times, as I'm sure you well know, the problems are not with the operational data as much as it might be with the reference data.
Yeah.
And when you look at things like LEI, USI, UPI, CEDOL, I mean, take your pick. And this is admittedly less of a data question, maybe more of a workflow question.
Mm-hmm.
Well, what types of capabilities does MarkLogic have to address the point that you raised around going back to the source and forcing the source to provide good data on an ongoing basis?
Yeah. It's a good question. So I don't think I need to repeat that because it's on the mic, right? So we actually have a customer in London, JP, and they do, MarkLogic is actually their workflow processing system, okay? So from that perspective, creating something that flags up the missing information is best done by an external entity. So you act as the aggregation layer. You then have a number of quality controls that are based on that. They analyze it, and then they can publish back in, and then they often send a message back up, which allows them to fetch that information, almost like that gateway solution, where they can still access the view of the information. The key to that process, and the advantage to it, is that normally what would happen is that you would flag this up. The data would not be in the database because it could have violated referential integrity rules, is a great example, right? And somebody upstream needs to kind of look at the log files to identify really what went wrong and then try and backtrace it. The nice thing within the MarkLogic database is two things. The first thing is that the data is already there, so you can actually look directly at it and see what arrived. Okay, so that simplifies that. More importantly than that, workflow, you sometimes actually want to report your incomplete data, right? So Anizing is a really good example of that, because if you create a new instrument ID, you can guarantee that in a real-time report, you probably reported that without a valid instrument ID because it doesn't appear in the reference data yet because it hasn't come back. So in that situation, you can actually do a couple of things, which is you can report the incomplete data or data that violates referential integrity rules, and then you can re-report it when the new version of it arrives. And actually, that's something that MarkLogic does very, very well with bitemporal. So you can actually re-report it, but you can also state exactly what was aware at what time. So if there are any other regulatory delve into it, you can actually categorically prove what was reported when and how the data changed and why it changed.
So not like this was some kind of order.
Exactly, yeah. And actually the provenance ontology, which I'm going to mention this afternoon. So the provenance ontology, and I mentioned here, that's a great way of doing that. It's a framework that's already been designed to effectively capture three things, which is who acted upon what entity and what did they do to it, right? So you can actually process that as well. Typically speaking, though, we don't provide the workflow. The workflow will sit out of us, but we act as a persistent layer for that workflow that allows you to be more optimal in terms of what you report and how you report it and the flow of it. Yep. Other questions? Hi.
Back to the architecture. Three different questions. First was, you mentioned that it's a good idea to create a hash key to prevent duplicates.
Yeah.
Is it at the overall document level, or what if I have a need to create a hash key within certain data elements with certain data within the document? Yeah. And then just curious about the other aspect you mentioned, validation rules within the MarkLogic store.
Yeah.
I mean, what type of rules would you put within the MarkLogic store versus outside the MarkLogic store? And if you can make a comment on when you're linking to reference data, how would I decide on whether I would embed the reference data within the document or to create some links?
So that's a good question. Okay, so three questions. That's awesome. So I've got to try and remember them all. So the first question was the hashing, correct? Okay. So the hashing question. The hashing is performed on the document content itself rather than the document level. Because if you're using the envelope pattern, if you were to hash the document as an entirety and then store the information within it. First of all, you'd be creating a hash of a document that you're now updating, but also you will be using potentially the envelope for tracking provenance. It could be used for lots of other system-wide functions, and they will change. So typically, if you imagine it a message format, the message will have a header, there will basically be a payload in it, and you perform the hashing on the payload. Okay? It's the actual content that you're trying to avoid duplication of rather than when it arrived. You know, the message header will have a date timestamp with a message queue ID and all the rest of it. That's not what you're bothered about. You're actually bothered about the content itself. The second question was, what was the second question? The validation rules. An example of that actually was what I just spoke about here actually, which is a legal identifier. As the trade arrives, it should have a valid ID, but sometimes it may not have a valid lie for some reason, in which case you may want to raise that up as an exception. There may be situations where, unlikely, but there may be operations where something arrives out of order within the database and it may not actually be within, it may not be contextually accurate. So for example, something is executed, it's out of order, and maybe the order actually arrives before the trade does. The trade can arrive before the order does for an upstream system reason. So there are a number, but it could also be as simple as, is the format of the field correct? Does it actually have the right date-time format? Does that trader ID exist? Does the customer ID exist within the bank? There are numerous lookups and derived values that you would want to check, because most guys in the room will tell you that, surprisingly, there's still a large number of trades that are actually written down and handed over to somebody to put into a booking system. So there's human error there. So there's a whole number of lookups and derived lookups and also typing that may necessarily be done. And then the third question was the reference data. Now that, I should remember that one, because that's a really interesting one. The golden rule of whether you materialize something within a single document and join it together in advance is, are you only ever looking for that joined at that point in time? Or, so if, and we've got a different sliding scale of this, of customers who do it different ways, and some of them are changing as well because the regulations are changing. But if I create a trade and my regulatory interpretation is that I only need to report the reference data at the point of trade, then it actually makes a lot of sense for me not to do the join at all, but actually to lump the reference data into that trade, job done, right? Because if the trade is cancelled or anything else, then we can reconsume that data or whatever it is. We can rework it. However, recently, we had a customer who used to do that, and now they're going to use our bitemporal capabilities because they've been asked to prove what was the reference data at the point that you made the trade. But reference data lags, right? Often the real world. So then in a situation where, take an example, where a credit rating has changed for a customer, and this is particularly important for best execution under MiFID II, you may actually need to be able to prove that their credit rating the next day was much better than it was when you executed the trade, and you did it fairly, but actually you didn't have that reference data because it hadn't been published at that point in time, or you hadn't received it yet. So the question is the data linked completely at that point in time? And if you don't have to cross-query that, and you don't want to ask different questions at different points in time on that join, in which case you materialize it. Okay. Hi. Yeah. Sorry.
Should we have the data like more like a flat structure and then reduce the number of joins, or is MarkLogic good with multiple links and fetch link on the fetch during the fetch time and all that?
So generally speaking, just like a relational database, joins are expensive, right? Always expensive. Looking up and doing joins is expensive, and avoid them wherever possible, okay? It's especially important when you think of scale-out architectures. So a scale-out architecture where you may have 30, 40 nodes operating, doing a simple operation such as get me the highest value. So the last version, this is actually a really big problem. Most of the trading guys in the room will turn around and snigger at this because one of the biggest problems is something that sounds so easy to do, which is get me the last version of every trade. right? And then tell me whether it's open, right? It's a super simple question. But when you've got 40 million trades arriving, you've got 1.8 billion trades in your trade store, that is an expensive question to ask at query time unless you've optimized your system to do it. So the golden rule is try and avoid joins wherever possible. If you're going to do joins, then there are certain ways that you can optimize those. But just like in a relational database, going 13 levels deep with inner joins is a real bad idea, right? And we're no different to that. Just because you can doesn't mean that you should. Yeah. I mean, Justin is pretty much our data modeling guru and probably could speak to you at length about this, I dare say. But yeah, is there anything you'd add to that, Justin? No? Okay. Any other questions? Okay, great audience. Don't forget, I'm back up in about an hour, so it'd be nice to see you all again. Just before I wrap up, actually, just remember this, okay? The big core concepts are, think about what your long-term goals are, whether you're going to extend your trade store and do something bigger with it. Develop that BA role, okay? They're going to be an absolutely massive asset to taking all of the business functional and non-functional requirements and making your project successful. And don't forget, when you're delivering this and you're aggregating, use all of your existing standards, right? And plan for predictable workload spikes. That's it.